Hello everyone. We are starting with the fixed prosthodontic topics now. Myself, Dr. Nikita Narayanan. I'll be covering various sections under fixed prosthodontics with special emphasis on the topics which are relevant to your NEET preparation. So the first topic I have selected is principles of tooth preparation. I have referred Rosenstiel and Schillingberg for the presentation. You guys can refer the latest edition of these books for further reading. Before starting with the principles of tooth preparation, we'll have a brief introduction on FPD. So as you all know, the components of fixed partial denture are retainer, pond tip and connector. So retainer is that part of the FPD that sits on the abutment tooth. Pontic is the part of the FPD that replaces the missing tooth, and the connector is the part that joins the pontic and the retainer. So the FPD has three main components. They are the retainer, pontic and connector. Abutment is a tooth or a part of a tooth or that part of an implant that retains a fixed partial denture. So the selection of the abutment tooth and its preparation is the most crucial step if you want to achieve a successful fixed prosthodontic therapy. So now we'll discuss in detail about principles of tooth preparation. Various authors have discussed it under different headings. Nevertheless, the ultimate essence is the same. So according to Schillingberg, the principles of tooth preparation are conservation of tooth structure, retention form, resistance form, structural durability, marginal integrity and preservation of periodontium. Rosenstiel has categorized these principles into biological principles, mechanical principles and aesthetic principles. So as the name suggests, biological principles are the factors that affect the tissue health. Mechanical principles are the ones that affect the retention, resistance and integrity of the restoration. Aesthetic principles are the ones that affect the appearance. There are various biological considerations that need to be taken care of during tooth preparation. The first and foremost is the avoidance of injury to the adjacent tooth, soft tissue, pulp and periodontium. Adjacent tooth can be protected with the help of utilizing a matrix band or the proximal enamel lip. The soft tissue is protected using a mouth mirror, your normal saliva ejector or an aspirated tip. The pulpal injury, which is the most common error in the preparatory stage, can be avoided with proper planning and sticking to the rule of conservation of tooth structure. Injury to the periodontium can be detrimental to the entire dentition. It most commonly occurs when there is a violation of the biological width. Various mechanical principles involved in the fixed prosthodontic therapy are retention form, resistance form and structural durability. Factors influencing retention and resistance are taper, freedom of displacement, length, substitution of internal features and path of insertion. Taper simply means the inclination of the axial walls with respect to the long axis of the tooth. So taper is the sum of the inclination of two opposing axial walls. In this picture, it's clear that the inclination of the opposing walls are 3 degrees each. So the taper of the preparation will be 3 plus 3, 6 degrees. So that's how you calculate the taper. For a preparation with parallel walls, that is if the axial walls are parallel to each other and to the long axis of the tooth, then the preparation taper will be 0 degree. That is when you get maximum retention for the preparation. As taper increases, the retention decreases. So we need to keep the taper as minimum as possible for all the preparation to get a decent amount of retention and resistance. So according to Schillingberg, the optimum taper required is 2.5 to 6.5 degree. And the clinically achievable amount of taper is 16 degree with a range of 10 degree to 22 degree. So that is the range of taper which can be given for acceptable retention and resistance form. Schellenberg has also given optimum degree of taper for each tooth. So for maxillary and mandibular anterior teeth, it is 10 degree. For premolars, it's 14 degrees. For maxillary molar, it's 19 degree, and mandibular molar, it is 22 degree. So that is the range, 10 to 22 degrees. So the maximum taper is given for mandibular molar, and the least taper is given for anteriors, both maxillary and mandibular anterior teeth. Next factor is the freedom of displacement. This simply means the ability of the restoration to get displaced from torquing or twisting forces in a horizontal plane. So this occurs when there is more than one path of insertion. Freedom of displacement again is inversely proportional to retention and resistance. That is, in order to increase retention, we need to limit the freedom of displacement, and this is achieved through limiting the path of insertion. So the tooth with single path of insertion will be more retentive than multiple path of insertion. The next factor is the occlusogingival length. It is an important factor in both retention and resistance. Longer preparation will have more surface area, and therefore it will be more retentive. That is, the length of the preparation is directly proportional to retention and resistance. This is because the axial wall will prevent displacement of the restoration by resisting the tipping forces. In the first picture, you can see the preparation with longer walls interferes with the tipping displacement of the restoration better than the short preparation. So the shorter preparation, the restoration gets displaced easily. In the second picture, you can see the length of the preparation is same for both A and B, but the diameter is different. That is, A is having a smaller diameter compared to B. In these cases, where the length are same but the diameter is different, the tooth with less diameter will resist the displacement better than the tooth with larger diameter. In cases where ideal taper and length is not achievable in a preparation, then resistance and retention form can be improved by incorporation of certain internal features, that is supplementary retentive features. These are box, grooves and pinholes. Box forms are used in cases where there is an interproximal caries or prior restoration. This serves a dual purpose of caries removal as well as improving the retention. Grooves, which are placed on the vertical walls, must be 1 mm wide and deep and should be as long as possible to improve retention and resistance. Pinholes are used in cases where there is insufficient axial wall length. The pin can be used to retain a core, which in turn will help in retention of the crown. Boxes and grooves are placed on the external walls and pinholes are placed in the internal walls. Next feature is path of insertion. The path of insertion is an imaginary line along which the restoration will be placed onto or removed from the preparation. So for a fixed partial denture, the path of insertion of all the abutments must be parallel to each other. The path of insertion must be considered in 2 dimensions, that is facial-lingually and mesiodistally. The facial-lingual orientation of the path can affect the aesthetics of metal ceramic or partial veneer crowns. For metal ceramic crowns, the path is roughly parallel with the long axis of the teeth. The mesiodistal inclination of the path must parallel the contact areas of the adjacent teeth. If the path is inclined mesially or distally, the restoration will be held up at the proximal contact areas and be locked out there. The next principle that has to be taken care of during tooth preparation is structural durability. So structural durability simply means that the restoration must contain adequate bulk of material to withstand the forces of occlusion. So this bulk must be confined into the space that is created by the tooth preparation. So what are the factors which influence the bulk of restorative material? These are occlusal reduction, functional cusp bevel and axial reduction. So it is determined that the occlusal reduction for a gold alloy must be 1.5 mm on the functional cusp and 1 mm on the non-functional cusp. For a metal ceramic restoration, it will be 1.5 to 2 mm on the functional cusp, 1 to 1.5 mm on the non-functional cusp. And all ceramic restoration should have an occlusal clearance of 2 mm. Next factor is the functional cusp bevel. Before going in detail about the bevel, we should know what a functional cusp is. I think it's more easier to remember what are the non-functional cusps with the help of Bull's rule. So the non-functional cusps are BULL, bull, that is buccal, upper, lingual, lower. So when we know the non-functional cusps, whatever cusps that are remaining will be the functional cusps. They are the lingual cusp of the maxilla and buccal cusp of the mandible. So you simply remember the Bull's rule for non-functional cusps. So what do you mean by functional cusp? They are the part of the occlusal morphology, or the part of the tooth that is subjected to maximum occlusal load. So it is necessary that the restorative material in this area should be of adequate bulk. If the functional cusp bevel is not provided, then the restorative material will be thin in these areas, that leads to fracture of the restoration. Otherwise, what happens is, if we don't give a functional cusp bevel, then the technician tends to increase the bulk, because otherwise the restoration fractures. So he tends to increase the bulk of the restorative material or over contour the restoration, and that will lead to a deflective occlusal contact. So it's always necessary that you give proper functional cusp bevel for all your abutment tooth preparation. The next factor that affect the durability of the restorative material is axial reduction. So the axial reduction, that is the reduction of the axial walls of the preparation, should be of adequate amount. Otherwise what happens is, the restorative material will be thin in these areas, or there can be over contouring of the restoration. Both are having detrimental effect on the periodontium. When we talk about marginal integrity, we need to understand that the restoration can survive in the biological environment of the oral cavity only if the margins are closely adapted to the KO surface finish line of the preparation. So it's determined that the metal castings should fit within 10 microns and the porcelain margin should fit within 15 microns to have a proper marginal adaptation. Margin design or the configuration of the gingival finish line determines the bulk of the restorative material at the margin. So this contributes to your structural durability of the restoration along with marginal integrity. So various finish line designs which we use are chamfer, heavy chamfer, shoulder, slope shoulder, shoulder with bevel, chisel edge and knife edge. So chamfer is the preferred margin for cast metal restoration. Heavy chamfer, shoulder, although slope shoulder are used for metal ceramic restorations. Chisel edge and knife edge margins are very rarely used. These are occasionally used on tilted teeth. The next principle of tooth preparation is preservation of periodontium. The location of the gingival finish line or the placement of the margin has a direct impact on the health of gingival and periodontal tissues. This will ultimately determine the success of your restoration. So it's always important to maintain a healthy periodontal condition with a self-cleansable margin. It's advised to keep the margin in the enamel whenever it's possible. Based on the placement, the margins can be divided into supragingival margin, at the crest or equigingival margin and subgingival margin. So supragingival margin is the most preferred one as it is easier to finish and easier for the patient to keep it clean. Subgingival margin is the least preferred one. It shouldn't be given unless it is indicated. So subgingival margins can be indicated when there is a caries or restoration that is extending subgingivally. Equigingival margin is given in cases of anterior or the aesthetic zone where a supragingival margin can have a unaesthetic appearance. Now let's have a brief discussion regarding abutment selection for fixed partial denture. The abutment tooth which we select for a fixed partial denture restoration should be able to withstand the forces that is directed towards the missing teeth along with the occlusal forces that are directed towards the abutment teeth. So whenever possible, a vital tooth should be considered as an abutment. It also should have sound surviving coronal tooth structure to support the restoration. A pulp-capped tooth should not be considered as an abutment unless and until it is endodontically treated. The abutment tooth also should have a good amount of supporting tissue that is healthy and free from any kind of inflammation. The root and the supporting tissues of the abutment should be evaluated for 3 factors regarding the success of a restoration. The factors are crown root ratio, root configuration, periodontal ligament area. So crown root ratio is a measure of the tooth which is present occlusal to the alveolar crest of the bone compared to the length of the root which is embedded inside the bone. That is the ratio of the length of the crown to length of the root. But here the measurement is taken from the crest of the alveolar bone. Optimum crown root ratio is 2:3 and the minimum is 1:1. Now when we talk about root configuration, this is an important point in assessment of an abutment's suitability from a periodontal standpoint. Okay, so the roots which are broader buccolingually, it is preferred more than a root which is completely round in cross section. Okay, so in posterior region with multi-rooted teeth, the root which are widely separated will offer better periodontal support than root which converge, fuse or generally present as a conical configuration. Okay, in cases of single rooted tooth, the root with irregular configuration or with some curvature in the apical third is preferred to the tooth that has nearly perfect taper in the end. Another consideration in the evaluation of abutment teeth is the root surface area or the area of the periodontal ligament attachment to the root to the bone. So this is described in terms of Anti's law. Anti's law states that the abutment teeth should have a combined perisegmental area equal to or greater than the perisegmental area of the tooth or teeth to be replaced. Perisegmental area is nothing but the periodontal ligament area or the root surface area. So in order to take a tooth as an abutment, we should first calculate the periodontal ligament area of the missing teeth, and we need to find out if the periodontal ligament area is of the missing teeth is less than or equal to that of the periodontal ligament area of the abutments which we are using. So if in the first picture we can see the missing teeth are second premolar and first molar. So the combined perisegmental area of the second premolar and first molar is equal to the perisegmental area of first premolar and second molar, which is intended to be a abutment. The average root surface area of each tooth has been determined, and it was found that the maximum is for the first molar, that is maxillary first molar, which comes up to 433 square millimeter. The least root surface area is for the mandibular central incisor, which is 154 square millimeter. For the maxillary central incisor, it is 204 millimeter square. For the maxillary lateral incisor, it's 179 millimeter square. For the maxillary canine, it is 273 millimeter square. For maxillary first premolar, it's 234. Second premolar, it is 220. First molar, it's 433. Second molar, it is 431. In mandible, for the central incisor, it is 154 millimeter square. Lateral incisor, it is 168. Canine, 268. First premolar, 180. Second premolar, 207. First molar, 431. Second molar, 426. So the maxillary second molar and mandibular first molar, the root surface area is same. It is 431. Now we'll discuss about different types of abutments. First one is additional abutment. It is the abutment which is used in addition to the primary abutments in cases of a long edentulous span or if the primary abutment is weak. For example, if there is a missing canine, a maxillary or mandibular missing canine, the primary abutments will be your lateral incisor and the first premolar. But since the lateral incisor is weaker, we will have to include the central incisor in addition to the primary abutments. So here the central incisor becomes the additional abutment. Next is pier abutment. So pier abutment is a natural tooth which is located between the terminal abutments that serves to support a fixed or removable prosthesis. That is an abutment which is bounded by edentulous spaces on both sides. Okay, so it is also known as an intermediate abutment. So in cases of pier abutment, we will have to give a non-rigid connector for your FPD. So the non-rigid connector will have a male and a female component. That is the female component will be a keyway and male component will be the key. The keyway should be located in the distal surface of the pier abutment, that is the central abutment. And the key will be placed on the mesial surface of the pontic in the distal edentular space. Okay, so the distalmost pontic, the mesial surface of the distalmost pontic will contain the key or the male component, and the distal surface of the pier abutment will contain the keyway or the female component. Next one is cantilever abutment. So the cantilever abutment is the abutment which retain and support the pontic only on one side. So there won't be two abutments. There will be only one abutment which supports the pontic. Distant abutment, the posterior or distal abutment which retain and support the long pontic in the anterior region. That is, the abutment will not be present next to the edentular space. The abutment will be present at a distant location from where the connector will be attached to give a pontic in the anterior region. So this is most commonly used in cases of diastema, where the patient wants to retain the diastema, and giving a normal abutment might cause a closure of the diastema.